In 1 through 6, we're asked to find from the equation the mean value, period, and phase shift for each tangent function. Notice that we're not finding amplitude since, strictly speaking, although a tangent function can have a vertical stretch, it won't have an amplitude because the function has all y values included in its range and is not restricted to between -1 and 1 like the sine and cosine function. Okay, so mean value, in other words, is the vertical shift of the function, so that's indicated by this +1 out here. The period, remember, for a tangent function, the period of the parent function is 180, not 360, so the period is 180 divided by the b value, which is 3, and so that's going to be 60 degrees. And then the phase shift is the horizontal shift. We're looking for that on the inside of the function or the inside of the tangent, and that is positive 5 degrees or 5 degrees to the right. In number 2, the mean value is our vertical shift. That's the amount that's being added to the tangent function, so that would be 3. And then the period would be the b value, 180 divided by the b value. However, before I begin, I may want to take this 2x plus 40 and factor it. That's not going to affect our period, but it will affect the phase shift. So once I factor that, the period is 180 divided by b, which will be 90 degrees. And then the phase shift is -20 degrees. Notice that I can't see the phase shift, strictly speaking, until I do the factoring on the inside of the tangent function. All right, let's take a look at number 3. If you want, you can rewrite this as -1 times the tangent of 1/5 x plus 2. Notice the 2 is positive, so our mean value is 2. Our period is the base period, 180 degrees, divided by 1/5. That's 180 times 5, which is 900 degrees. And then the phase shift is the horizontal shift. That's indicated by addition subtraction on the inside of the tangent function. There is none, so our phase shift is 0. All right, for number 4, mean value is the amount that's added to the tangent function, so that's 0. Our period is 180 divided by the b value, and the b value is the coefficient of x, so that's 180 divided by 1/2, which is 180 times 2, or 360. So our period is 360 degrees. And remember, we cannot find that phase shift unless we do the factoring. So I'm going to factor out 1/2, and we need to be especially careful when factoring out 1/2. 1/2 times x minus 20 degrees is the same thing as 1/2 x minus 10. So that means that our phase shift is 20 degrees. All right, number 5. The mean value is the amount added to the tangent function or the vertical shift. That's 5. The period is 180 divided by the b value, and the b value is 9, so that's going to be 20 degrees. And then our phase shift is the amount that's added to the inside of the tangent function. That's 0 degrees in this case. In number 6, mean value, -2. That's the amount that's added to the tangent function. The period is 180 divided by the b value, which is 180 divided by 1/3. That's 180 times 3, which is 540. And then in order to see the phase shift, I must factor that inside to 1/3 times x plus 150 degrees. And that means that the phase shift is -150 degrees. For 7 through 10, we're going to graph multiple cycles of the tangent function. And for the tangent function, 2 of our 5 anchor points per cycle are actually just asymptotes to the graph. So we're actually going to graph 3 points for each cycle plus the 2 asymptotes, and then graph additional cycles if necessary. We'll create a table of values to generate 1 cycle. And so I'm going to input my x values in order of operations, multiply them by 3/2, and then take their tangent values. And then finally, last column here, multiply those results by 3. it's important to know where the parent function points are. Those are the inputs and outputs for the tangent function. So the angles are 3/2 x, and their tangents are tangents of 3/2 x. So here's where I'm going to put my angles. But remember, for the tangent function, if we want to divide the cycle into 4 parts, we must divide the cycle of 180 by 4, which gives us 45 degrees. So we're going to go, instead of by 90 degrees, we're going to go by 45 degrees. So 0, 45. And, in fact, I almost forgot, we're going to actually start at -90 because that's where an asymptote is. So -90, -45, 0, 45, and 90. Tangent is undefined when the angle input is either 90 or -90. Tangent of 45 is 1 because that's the triangle where our opposite and adjacent sides have the same length. Tangent -45 is -1, and in between tangent of 0 is 0. Okay, multiplying each by 3, or rather by -3, which is going to invert the graph. We get the end y values, and then in order to undo times 3/2, we're going to think of solving an equation. 3/2 times x is equal to 90 for that last value, so we'll multiply both sides by 2/3, and that will give us an x value of 60 here, and 45 times 2/3 is 30, 0 times 2/3 is 0, -45 times 2/3 is -30, and -90 times 2/3 is -60. Okay, we are ready to graph, and where the y values are undefined at -60 and +60, there are vertical asymptotes. Notice the vertical asymptotes will be evenly spaced, so we can sketch in the remaining vertical asymptotes for the other cycles. Now let's sketch in that one cycle. At -30 degrees, the y value is +3. At 0 degrees, the y value is 0. At 30 degrees, the y value is -3, and then just sketch in the shape of the tangent function. And then we'll do that for the remaining cycles to fill out the remainder of the grid. In number 8, we can see that there are subtractions and additions, so if we want to go with our new origin approach, the new origin is at 90 degrees, 2. I'm going to graph that and sketch in very lightly my new x and y axes, then create a table of values for a related function that takes the addition and subtraction out of it. And if we take the -90 and the +2 out of it, we're just graphing y equals tangent of x. So -90, -45, 0, 45, and 90 are the angle measures. Undefined, -1, 0, 1, and undefined are the y values. So we have, let's sketch in our asymptotes first, 90 degrees to the left of the new origin, 90 degrees to the right of the new origin, and of course our asymptotes here are evenly spaced, so I can sketch in the rest of the asymptotes. And then sketch in the remaining points for the cycle. So 45 degrees to the left of the new origin and 1 down from the new origin. 0 degrees to the left and 0 up. 45 to the right and 1 up. And that's the graph of one cycle. And then we can sketch in the remaining cycles. For number 9, before we begin sketching, we're going to want to factor. So y is equal to the tangent, and on the inside we're going to factor out that 1/2, and that will leave us with x plus 30 degrees. So new origin is negative 30 degrees, comma, 0, because there's no vertical shift. So I'll sketch in that new origin. So now I'm marking off the new origin, and I'm going to sketch in a new y and a new x axis, very lightly. And then we're going to use a related function that takes all of the addition and subtraction out, so that would be tangent of 1/2 x. Making a table of values, x, 1/2 x, and the tangent of 1/2 times x. The angle measures go in the 1/2 x column. And their tangent values in the next column. And then to get from 1/2 x to x, we multiply by 2. So negative 180, negative 90, 0, 90, and 180. And so my asymptotes will be 180 to the left of that new origin. So not on 180, but 180 to the left of the new origin. 180 to the right of the new origin. And then 360 to the right of that. So we're actually not going to see that any more asymptotes in this graph. Let's sketch in one cycle. So 90 to the left of the new origin and down 1. 0, 0's on the new origin. And then 90 to the right of the new origin and up 1. And there we can get one full cycle. And then we can just repeat. So 90 to the right of the next asymptote and 180 to the right of the next asymptote, and we get part of that additional cycle. Last one to graph by hand, y is equal to, I'm going to rewrite it, negative 2 times the tangent of x plus 1. So from our new origin approach, there's no phase shift or no horizontal shift, but the vertical shift is 1. So I'm going to draw in a new origin at 0, 1, and my y-axis doesn't change. My new x-axis that corresponds with that new origin is 1 up. And then from there, I'm going to graph that related function y is equal to negative 2 times the tangent of x. Table of values approach, x, tangent of x, and negative 2 times the tangent of x. Let's put our angles in that x column. So those would be negative 90, negative 45, 0, 45, and 90. And their tangent values undefined, negative 1, 0, 1, and undefined. And then multiply each by negative 2. And now let's graph from that new origin, sketching in the asymptotes first. So 90 to the left of the new origin, 90 to the right of the new origin, and then of course our asymptotes will be evenly spaced from there, so we can get one more in there. And now let's graph from that new origin, 45 to the left of the new origin and up to 0, 0, 45 to the right of the origin, and 2 down from that new origin. Make sure that you're graphing from the new origin and not from the old one. And then we can sketch in our additional cycles. And we can't get a full cycle there at the end, but we can get something. And same thing on the other end. We're not going to get that full cycle in, but we can sketch what remains of that one cycle on the left.